Okay.
Should I open my mic or how
Yes. I'm gonna mute myself.
Can you Okay, Louis Simon, can you hear me?
Yeah, perfect.
Okay. So I just wanted to do like a very short description of what I'm using for my data collection. So right now I'm doing some tests with my instrumented insole. So basically I need to record some biomechanics data and also force plates data to compare that with the pressure and the motion data that I'm recording with my insole. So I'm using two systems that are linked together. The first one is Vicon and the second one is the BERTEC treadmill. So for the BERTEC treadmill, it looks like that. We have like a double like splitted belt treadmill with two force plates. They are completely like the data recorded are separate. So we have data for one foot and for another one. They are not linked, so we don't have crosstalk. We can control the speed, the acceleration of the belt individually. The output would be the force, the moments, and also it computes the center of pressure trajectory for each foot. This is an example of the user interface. We can see in real time the force applied on the force plates, and we can change the speed on the right. And we can see here the crop trajectory at the bottom of the user interface. The one that I'm using is way more simpler than that. I just have the threshold for my speed and my acceleration. I don't need to display all the data in real time. And this treadmill is linked to the Vicon system. So the Vicon system is a motion capture system where the goal is to track, record, and analyze movement of people or object. That it can be used to track motion of robots, for example. And the principle is that they are using optical cameras that are emitting some lights, like visible lights and infrared lights. This light is going to be reflected by markers that are like silver markers, and based on that, the camera can track these markers. This is an example on the bottom of the slide of the setup that is usually done. So we have the camera that is encircling the capture volume. So we can have like different point of views of the different markers for a more robust recording. All the cameras are linked to a GigaNet box. It's used to kind of go from analog data to digital data, and the data are sent to a host PC. We are using the Vicon software, which is called Nexus, and we can analyze the data, see in real time the different graphs for the force plates, for example. The cameras are linked to the GigaNet, but also the force plates are linked to the GigaNet, so we can see everything on Nexus. So this is an example of the user interface. On the left, you can see the resource panel. It shows like the cameras that are connected, the force plates, the BERTEC system, for example. And we can also set up the different characteristics for the user. For example, we can define a specific set of markers. For my project, I'm using 3 markers for each leg. So I can define everything there. Then for the view, which is the number 2, we have different type of views. We have the 3D perspective, which is basically the volume with all the cameras, the force plates. It's just the setup in general. It's virtual. Then you have the camera views. So usually it's like a black image with just reflective points when there are markers in the volume. But it's just the viewpoint of each camera. And then you have all the graph. So you can plot in real time the force, the moments, even the center of pressure, or even the raw data obtained with the force plates. Then on the right, And the number 3 is the tools panel. This is where we can prepare the system. So basically, we can do the calibration, set the volume origin, mask the cameras, and other things. But for now, we don't need that. Then you have the label and edit panel, where basically I can label all my markers, and usually it can do it automatically once I've pointed each markers to one name, for example. It should do it for the whole trial, but sometimes markers get lost, so I need to label them again. And you can fill the gaps when a marker, like the tracking of a marker is missing, you can fill it with like mathematical functions that is going to predict the trajectory of the marker. Then you have the processing pipeline, which basically allows you to filter the data, do some parameters extraction. For example, for the get cycle, I can extract the event, like the gate events, for example, heel strike, toe off, and see how many get cycles we have. Then you can export get parameters like step duration, stride duration, etc. And you can export the data in different type of files. And the fourth section, it's the data management section, where you can see the history of the data. You can see how the data have been processed. If you have C3D files or I don't know, CSV files, so you can check everything, and you have the percentage of quality of your data. For example, if you have like a marker that missed data, you can see it there. It's going to be shown. You have 2 modes on Nexus. You have the live mode and the offline mode. So basically the live mode is the mode where you can see your subject in the volume. You can record the trials, but then to process the data, you need to be offline, and you can just visualize the data and do whatever you want with the processing pipeline. So for the calibration, so the first step is to calibrate the system, Vicon and BERTEC at the same time. So the first step is to mask the cameras. So as you can see here, you have like a black image with some greens and white spots. And basically it's reflective, like unwanted reflection. So you need to mask all the markers that you're going to use. It can be like reflection on the ground. It can be, I don't know, something that is on the desk or whatever, but it needs to be fixed. Like it shouldn't move. So then when you start masking the cameras, it's gonna put like gray area on the spots. So it will avoid to detect this reflection as actual markers. So you can do that for all the cameras. Then you need to calibrate the cameras. So it's gonna describe the capture volume to the system and enable an accurate 3D reconstruction. So to do so, you need like an L frame, which is also called a wand, and you're gonna move it by doing some waves. This is an example, and you can see it in real time. It's gonna create like rainbow waves, and on the bottom of the window, you can have like the number of wands that are measured, and it's gonna automatically stop when there is enough wand recorded. So then you have to fill all the volume with the wand, and then it's gonna stop like that. So this is an example of the cameras, the count of wand recorded, the error committed when you're calibrating the cameras. But then the thing is, when you're doing that, it's gonna place the cameras randomly in the volume because it doesn't know where the origin is. So you need to set up the volume. So this is the step that comes after, and it tells the Vicon system where the center of the capture volume is and what is its orientation. So usually when you don't have a BERTEC system, you can just use the L frame and put it on the force plate, and then you start recording you start setting the volume origin. But with the BERTEC system, you need to use an extra software, which is the VSK creator. You need to take some measurements of the force plates, and the treadmill, you have to enter everything on this software and user interface. You have very specific like placement for the markers. You need 4 markers, one at the bottom of the treadmill on the right, then 2 on the left, and 1 again on the left side on the top corner. And then once you've done that, it's going to generate a VSK file and a text file where you have all the parameters for the volume origin, the dimension of the BERTEC system, and you can enter that in the device parameters of Nexus. Then, so as I explained, you need to place the markers. This is an example of the markers placed. Like you have ports on the black parts, and you can put it like aligned to that. Then you can start setting the volume origin. So this is an example of the cameras that are now in the right position compared to the force plate. But then if you want to record motion, you need to place markers on the body, and there are some standard models that have been developed. You can use custom, like create a custom skeleton, but it's easier to use a plugin gate model, for example. It's like a very standard model developed and it's already in the Vicon software. So you can either do the complete skeleton, so you have like very specific markers like on the big toe, the ankle joint, the knee, etc., or you can just do the lower limb, or you can even do less than that. So this is an example in the middle of the plugin gate marker set for the lower limbs. And this is the example of the lower limb skeleton you would obtain in Nexus. But for my project, I only need the last 3 markers, the one on the calf, the one, not even on the calf, but it's the ankle joint, the toe, and the heel, but we cannot see the heel here, because I only need to extract some gate parameters, some gate parameters, and for that, it requires just 3 markers per leg. So this is an example of the setup with Thomas. We have 4 Vicon cameras, 3 in front and 1 behind Thomas. And then we have 6 reflective markers. We cannot really see them, but it's on the shoes and on the ankle joint of Thomas. Then we have 2 force plates and the 2 instrumented insoles that are attached here with like pressure tape. It's not really tape, but it's like a brace, yeah, straps. Then for the protocol, I'm asking the subject to do like a synchronization step, because we need to align the timestamp of Vicon with the timestamp of my instrumented insole. So basically they have to apply 5 times the pressure with the heel on the right force plate. Then we will notice like a pattern in both signals, and we can do a cross correlation, like use a cross correlation function to find the similarity in the 2 signals, and then it will compute the delay. Then I'm asking the subject to do 3 times a 6 minutes walk test at 3 different pace. The first one is the slow pace, then normal, and then fast. And then we have to redo the synchronization step, because if there is a drift, we need to see how much drift we have. So basically, we need to compute the delay at the beginning of the trial and at the end, and then compare the 2 delays. For the pipeline, I'm using, first I need to label the trial, and then I'm going to trim the trial to have like very clean data. And I need to fill the gaps if needed. Like usually it's needed, because for like a trial of 6 minutes, obviously you will have some gaps. And then I'm extracting some gate cycle events and then gate parameters. And then I can extract the C3G files. It's for the markers positions. And then I'm extracting CSV files, but it's just for the force moments and center of pressure. Then I save the trial as a C3G and PSK file. This is an example of the 3D perspective of my setup with the 2 force plates and the subject working on the force plates. And here you can also see the graph of the force on the Z axis during the trial. So this is like I'm done. Thank you for your attention. Do you have any questions?
How do you sync the data to the gate cycle? Does it automatically, or you need to like manually place like where the
You mean on Vicon or
yeah,
on for my instrument insoles?
insoles? I guess you're
Yeah.
doing it by yourself, but for the Vicon, does it do
For the
automatically?
gate cycle events,
Yeah.
actually they are using I think they have a threshold in like inside the software where they can see the force plate and see, oh, okay, we have this value going below this threshold, so I can say that there is a heel strike. So it's gonna start counting the gate cycle like that. It's based on the force events actually, but for the gate parameters, I think it's the mix of force plate events and also the position of the markers.
So you don't have any like post processing to do to find the gate cycle. It actually give it to you.
Yeah, for the Vicon system, no, I don't need that. For the instrumented install, it's already incorporated in the algorithm, so I can just extract them afterward. But yeah, I'm saving everything on the CSV file for my instrumented install. You have any? No, because we had an issue this summer. There were flooding, so the Grail is dead. So we found a new lab in Laval with Professor Begon, and he has the BERTEC system. It's not the Grail, it's very similar. You don't have the augmented reality screen, you only have the treadmill and the cameras, and it works the same way.
How about the session?
It depends. For example, with Olivier, we had to adjust the threshold for my gate parameters extraction for the install because they were a bit like the values were a bit higher. Usually, like the trial itself, it's like between 20 and 30 minutes. But then before we have to do the calibration of the system and prepare the subject.
It's longer to get there than to
Yeah, yeah. And it's like very fast because you only need to walk continuously on the treadmill. While in Boston, I had to ask the subject to do like different back and forth because we only had like force plates, like a square, and they had to hit the force plate multiple times.
You talked about the drifts.
Yeah.
Can you explain?
Like basically sometimes with the clock, for example, I had this issue with my Arduino in Boston. The delay is increasing while the trial is going on. So for example, at the beginning, I can have like 100 seconds of delay, and then at the end, I can have like 200 seconds of delay. So you can have like it can be linear, but like the easier way to to model it is to say that the drift is linear. So basically, you're saying that I don't know, the delay is like a coefficient multiplied by the time, and then you can find the drift that is added to the actual delay. But for now, with the Raspberry Pi, I don't have any drift, so it's fine. Yes, from the clock of the Arduino. Because sometimes you can have like, I don't know, delay the sampling frequency of your Arduino. So for example, it's not very like for the Raspberry for the Arduino, the delay is not like very precise when you add it in your code, and the sampling frequency is kind of changing. So
because you're running your loop without a specific set time.
No, I'm using a delay.
Yeah,
so
but that's the reason.
Yeah. But for now, with the Raspberry Pi, I'm using the clock of the Raspberry Pi, so it's fine.
And that works okay.
Yes.
Okay.
The delay
Even
exactly
with this delay, sometimes it depends on
the delay is not the
Compiling.
right way to do it. Yeah, you need to put an if function with the millisecond counting.
But even with that, sometimes the clock, like the measurement on the time is not accurate enough. If you have like really sensible points. Like with the robotic hand, that's the problem that we're facing in terms of trajectory control.
Mm-hmm.
You know, we cannot do the trajectory control because of that. And the way to do it, so with the computer, that's the problem essentially. It's possible to maybe use a dedicated thread on the processing of the CPU, so you have a better measurement of the delay, or use a dedicated. So they suggest that you use a Jetson, maybe.
Mm-hmm. But
or even Raspberry Pi.
for her, it works already with the
Yes.
but it's with Raspberry Pi, right?
Yeah.
So maybe it works with the hand too, if the CPU is powerful.
Yeah. We'll see. But yeah.
That's a good subject to to give to an intern.
Mm.
Okay, so any other questions? I have lots of questions.
Okay.
So I start with the very basic one, and I want you to explain it as detailed as possible so
Mhm.
everyone understand it, even if they're not in this field. So what's the objective of gate analysis?
You mean for my project or
No, in general. So when we talk about the gate lab,
Oh, okay.
what's the objective and what are the measurements? What do we usually measure?
We are usually measuring the angle of the joint, the velocity, the acceleration, and it allows us to have an idea of like the gait pattern of the subject, if there is any deficiencies in the gait pattern. You can also see the forces and moments applied on the ground. So you can track the center of pressure trajectory, which is basically the projection of your weight under your foot. And see, it gives you an idea of the gait progress and the gait stages. And you need markers on very specific anatomical segments and spots. But to do that, to extract the different angles, velocity, acceleration, all these informations, you need a model because we need to modelize the human body to then, based on the position of the markers, have an idea of the angle of the joint, the velocity. So for that, they have created some standardized models, like the plug-in gate model. But it can be used for a lot of things. It can be also used for measuring compensatory motions. For example, if someone has some muscle weaknesses, it's gonna compensate these weaknesses by doing other motions or involving unwanted motions in just doing a trajectory, for example. So you can record that and see what's added compared to healthy developed subjects. Yeah.
So for that biomechanical model, this is a standard model. So for that, you have specific placement
Yes.
of the markers. So, and each marker corresponds to a specific place. So you try to
Yes.
add it to that specific place, like different joints,
Yes.
and it creates, so
The
it
skeleton.
somehow accounts for the differences between different biomechanical parameters of different subjects, right?
Mhm.
So you do that, and the other thing is about what you said about the force play. So you're talking about kinematics, and then one dynamical aspect, which is the force plate. And you measure the force, but you said you measure the COP.
Yes.
So
Because we have the models.
yes. So what the COP indicates when you measure it in a gait analysis?
It indicates where the body is in regard to the foot position, I would say. Like, for example, if you're starting the stance phase, which is basically when you start putting your foot on the ground, your body is a little bit in the backward, and then you're moving forward, and that is going to be reflected on the cup trajectory. So
what is COP, just to be
center
clear?
of pressure. So
Like
basically
it projects what?
The center of mass.
Center of mass projected on the area.
Yeah.
So if sometimes like people are deficient in terms of the movement or in terms of balance, basically. So there are balance trainings based on COP.
Mhm.
So when you stand up, you just don't move, but you can change the center of pressure. And sometimes there are games you can see on the screen with just some objects that you can move by changing your center of pressure. So in gait analysis, we check those center of pressure and look into what they implicate in gait. The other thing is, so for your specific project, why do you do gait analysis? Not for the insole for like the exoskeleton?
And for the exo, because for the control system of my exo, I need some specific information on the gate stages, and I need a like kind of a gate assessment to know how I can assist the subject and how much I need to assist the subject. So for that, I'm gonna use the center of pressure trajectory that I will be predicting with my insole to know first where am I in my gate stage, my gate phase. So depending on where which stage, which phase I'm in, the requirement for my torque that I need to apply to the ankle joint will be different. And also because based on that, I can know if my exoskeleton is gonna create some unbalanced motion. So it's gonna create some perturbation for the subject.
Here, you will determine what gait phase you're in solely based on a model trained with inputs from the
But I also
cement,
the
sole?
the sole.
Okay.
And I can also use some like the encoder and the actuator to have a better idea. But the objective is to put it in a cost function, at the end, to put the center of pressure trajectory in a cost function to like have kind of a standardized scope trajectory from healthy patients and try to stick to this trajectory, even if you have disabilities. So the objective is to go back to a normal trajectory.
And are you using like 2D center of pressure? Like, is it some? But you can only act on 1 degree of freedom. Sure. So what's the advantage of using? Will you need more data to understand how it moves on a plane instead of on a line?
It's not on a line, so on the,
would it be better to just use it in one direction since you understand?
I understand your question because we don't have a degree of freedom in the eversion inversion.
You can't do anything about it.
Honestly, I don't know. Maybe, but the thing is because the cop trajectory is a little bit like that. I need this information, but at the same time, if I'm trying to assist during the stance phase, to put I think it's more the progression of the center of pressure during the stance phase that I need to assist. But that's a good remark.
The other thing, so you have other modalities you want to measure on your analysis for your specific project with your exoskeleton. And with the system, with the Vicon system and with the system, how would you synchronize all of that?
With the exo?
With the exo, yes.
Everything will be linked to the Raspberry Pi. So I will do the same thing as now, I think. Like doing the signal alignments and
when you do, what we have in your experiments, we have like data, unified data acquisition system. Even when we apply perturbation to virtual reality, we take another wire that goes into the data acquisition system. So when we just start recording, everything is synchronized with the same timestamp and with the same system.
Yes. I didn't think about wiring the exo to the system. I was thinking just starting the exo, or starting the exo with the subject on the treadmill, and then starting the recording on Vicon, and then do my trials as I'm doing with my instrumented insole. And use the timestamp of the Raspberry Pi and the Vicon and then synchronize everything together.
But there is a delay, right? So when you're getting data from your kinematics, from your Vicon, it says that, for example, you are on the trajectory and on the pattern, you are here based on the delay, based on the time passed, right? But in your Raspberry Pi, it measures your insole stuff and your movement, the kinematics from the exoskeleton. Maybe you're here or here because there's a delay between the systems. There's a time difference between these two systems, right?
Yeah.
So they're not. So how would you account for that?
But if we remove the delay with the signal alignments, would it solve the problem? I'm not sure.
Yes,
if I'm
but
doing that.
you can do that, but how would you do that?
The same way as I'm doing that, like applying, for example, pressure with the, like I would need to, maybe not. But yeah, I need a synchronization step. So I would apply pressure on my heel and then I will recognize the pattern because I'm not directly using the Vicon data to feed my EXO algorithm. So I don't need it to be like synchronized directly. I can do it post-processing.
And with the experiments that you showed us, I saw Thomas wearing
A backpack, yes.
Was it like symmetrical or
no? The backpack was too small, so I need to bring the bigger one.
Backpack for children, so
Yeah.
that's why like it's very small, so that's why it's.
But
So-
Olivier could put it on his back, but I'm gonna bring that. We have another one that is bigger, so I'm
Okay,
gonna
that's
use
good.
this one.
So
Yeah,
John,
just to be comfortable when
Yeah.
walking.
I
does
felt
it
like a giant.
it introduces like asymmetrical
Like it's a
things.
back brace for you.
Yeah.
Ready
Okay,
for the next
but-
example.
Given the synchronization, is it practical to use unified DAG? Like
Yeah, and
to have all of them in the same time because you might need a trigger to start your data acquisition or I don't know. Because at the end, if you don't have if you don't record your data in the same device, or in other case you have multiple cards to record your data, you need to synchronize them.
She already does that.
Yeah.
I think that
Yeah, I'm synchronizing my data post-processing, like after the trial, when I'm processing the data. Yeah.
you're
Yes.
and okay.
it should be a little bit different. When I'm there with you for the experiment, I will explain it to you.
Okay.
And Vicon does it. Vicon includes like a
Yeah,
data
okay.
acquisition system that you can input even the EMGs to it, right? So when you collect data, we have an EMG system, let's say the wireless EMG system that we use, it has its own data collection.
Mhm.
You can just plug it and just start and then start that, or maybe synchronize these. But the inherent delay that is in the system, you cannot account for that. I mean, I understand that you're trying to synchronize post-processing, but it's good. It will reduce that error, but at the same time, it's impossible to just
Yeah.
make sure that that works. For your case, it's quite essential because we're doing system identification. That's important. But for her case, the analysis and what we infer from the analysis is more important. So we shouldn't be like really picky about this for her experiment, but I can show you. So if we face some problems in the future, you can do that with
Okay.
data acquisition.
Yes, but I think we need to find a way to plug the motor, like because the
No,
the
not the
data
motor.
just the instrument
You
itself.
need the measurements.
For example, the Raspberry Pi sending the data.
Yeah, something like that.
Okay.
Something like that. The
Okay.
measurements,
But
or a unified measurement. So you have the sensors, but you translate them on board to, I don't know, whatever the COP, or you can send that
Okay.
to the data acquisition card, so it gets synchronized. But it depends on the application. I will explain it to you.
Okay. Perfect. Thanks.
No
I
problem.
had one final question. Is there significant difference, I really don't know, between gait cycles for adults and like children?
Yes, because I mean, what do you mean for the trajectory or for
I don't know, but like
For the speed,
the geometry alone of like
no? Like
physiology.
usually the pattern, the trajectory is usually the same.
Okay.
It depends on the age actually, because when you're very young, like a very young child, he's learning to walk, so the
Yeah.
center of pressure is not like accurate. But I mean, I think children above like 5 or 7.
When they know how to
Yes,
walk,
it's
there's no
pretty
issue
far the
like
same.
physiology,
Yes.
the size of the thing. Okay, good.
But just the duration is different.
Yeah, shorter.
Yeah.
Okay.
Have you seen anyone, connect the EMGs to that system? I'm pretty
Yes,
sure.
in Boston they were using
No,
that.
they're not in Boston.
No, I don't.
Okay.
But I've seen that there are some extra analog plugs, so we can do that if necessary.
The other good thing about BERTEC is that it's capable of
Yes.
doing incline.
Yes.
So if you want to apply more, I don't know, severity or resistance to the movement, you can check different incline and see the level of assistance that your exoskeleton is providing.
Yeah.
Okay, so the other thing about the treadmill, so you have a model. I'm curious. I never did this. So you have the treadmill and the Vicon system with the biomechanical model of the gate. So when you, does this translate? So you're doing an over treadmill movement.
Yes.
Does this translate into like a over the ground movement? So does that catch these things? Like
Yes, you mean like when he's walking, is he
Can
considering
you
that the
visualize
foot
it?
plate is the ground?
but can you visualize it? Like you're doing in place movement.
Yeah.
Like
Oh,
you're
yeah,
doing
it's
this. But
visualized.
when you visualize it, does it visualize us like moving?
Oh,
from
no, it's
distance?
visualize it on the treadmill.
Okay.
So it seems like it's stationary, but just the legs are moving.
Okay. It's just for
Yeah.
for the purpose of visualizing it. There's no significant difference, but
No.
it gets the cadence, step height, and step length, no problem. But in terms of visualizing, that would have been nice if
Yeah,
I
to
mean
see
it's
like
not very
Yeah,
hard to
the-
do.
You have the speed, so you can
Yeah,
like, artificially do it.
Yeah,
You add
because
speed to your
yeah.
data. But
Yeah,
that-
exactly.
That could be nice too.
If these the BERTEC and Vicon, they can be synchronized, and I think they can.
they are
because,
synchronized.
well, I think it's
it's
possible.
possible.
Okay, great, perfect. I'm done with the questions. Good. So
Good.
let me stop the recording.
What was the objective of